So here's the part 2 of this problem. So we are going to solve for letter B, that is the swell at point 2. So this one, we are solving for this. So you have the given. So let's now solve. Okay. Now first, let's analyze. So here's the drawing. Okay. That's the drawing. This is point 1. This is point 3. And this is point 2. So you have here H1. We already solved for that one, for the first part of the video. Now for the second part, we are solving for this H2. Okay? So then what we can do is let's analyze here point A and point B. Okay? Let's analyze there. And then we could put that one into a manometer. So like this. This is PA and this is pressure B. Now there's a swell here and there's a height there. Okay. This is H1 and this is H2. Now the difference is here. This is the difference and let's call that HW. And let's call this HW. Okay. So that's the analogy. So with that, I could say that we can create an equation wherein you have PB minus PA rho G equals, that is HW. Okay. Of course, if this is water, seawater, this should also be seawater. Let's call this equation number 1. Okay. Equation 1. Now, we could now solve if we have a pressure at A and B. We can now solve for the HW. But unfortunately, we are only given with the pressure B, that is 22 inches mercury. Okay. Now, another thing is that we can do is at point A and B, wherein using the Bernoulli equation, you have PA rho G at 2G, it should be rho G plus BA squared over 2G plus ZA equals PB rho G plus B at B, so velocity at B, then you have ZB. Now, if you look at it, this one, if this is 0, so the elevation of A and B are the same, so they will cancel out. Okay, they will cancel out. Now, it is assumed that the velocity at B, that is at the eye of the storm, the velocity of air is 0. So you will end up with these 3 terms. So you have now PB minus PA over rho, then you have G equals B at A 2G. Now this is also head. We just call that H, but that is not the same as HW because this is water and this one, the velocity we are referring to is air, so it should be air and this should be air. Okay, So let's call this equation number 2. Okay. Now, the problem is, what is the relationship between these two? Okay. This one, this is feet H2O or feet water. This one is feet air. Yan. So, don't mix it up. There's a difference between the two. Now, the question is how to convert. How to convert the HW to HA or HA to HW. So, conversion. Convert HA to HW. Although they have the same feet, they have the same height, but the substance is different, so they are different. Okay. Now, how to convert? We all know that pressure is the same. Okay, meaning if you have PSI, irrespective of the substance, whether mercury or water or air, they are the same. Okay, PSF, they are also the same. So we could say that to compute for pressure, you have the equation rho air G, then H air, and the same also with water, G, then H water. So now you have a relationship between the two. So the relationship is just HW rho A, then you have HA, then rho W. The G will cancel out. Let's call that equation number 3. Equation 3. Okay. Now, there's a given seawater density that is 64, but there's no, but we have air that is atmospheric. Okay, that is not the same as the density of air at this point A. So there. So that density is in the atmospheric standard pressure, that is 30 inches Hg, and the temperature would be a standard temperature. But in this case, it is not 30 inches mercury. So, how to know the density of air with the given density of, let's put it this way, density of air atmospheric, and that is 0.076 pound mass per cubic feet. Okay. Now, we can convert this density into another density, okay, with different pressure by using the ideal gas equation. The ideal gas equation is PB equals mRT. Or let's rearrange it, that is P density equals RT. Now, assume that the atmospheric temperature is the same the temperature at point A. Let's just assume like that. Okay? So with that, you now have P ATM, then rho ATM times R, then you have PA, rho A, then you have R. The R will cancel out, so now we could determine the value, the relationship of the air at that point A and the density at atmospheric condition. So let me rearrange rho. Now it's what's that again? Rho, it's PA, rho ATM, then you have P ATM. So let's call that equation number 4. Okay. Now if you have that, this is now given PA. Okay. Now PA, in computing for the density, let's assume that PA is almost the same as PB. In this case, just solving this one, and that is 22 inches Hg. If you have that, we can now solve for the density of air. Then let's go back to the solution. Now let's compute for the density of air. Okay, density of air now, it's PA. Okay, here's the equation PA. What's PA? That is 22 inches Hg. I will not convert that anymore because it will just cancel out. Then the atmospheric pressure is 30. Then the density, now it's 0.076 pound mass per cubic foot. So the density now would be 0.0557 pound mass per cubic foot. So again, don't round up in the next calculations. Just don't round up in our quiz. If you have that, okay, if you have that, you now have this one. We are computing for this HW. How about HA? So let's see from our previous equation what is HA. This one. Okay, HA, from this equation, you have BA squared, then 2G. Now, what is the velocity at A? The velocity at A is 155 miles per hour. Okay, so 155 miles per hour. So 155 miles per hour. Then you have in 1 mile, you have 5 to 80 feet. Then in 1 hour, you have 3600 seconds. So I square this. Then divided by 2 times 32.2. This is feet per second squared. So the answer is feet. So HA now, it's 802.4914 feet of air. Again, that is HA, that is not HW. So let's convert this one. A while ago, you have the equation number 3. Equation number 3, wherein you have HW, rho A, HA, then rho W. So we computed for this one. Okay. So HW now, it's 0.0557. Okay. They will cancel out, so no need to include the units anymore. So it's 64. Then HA, it's 802.4914. This would now be in water. That is 0.6988 feet. But again, that is not yet the answer because we are solving for H2. So H2 should be H1, HW. So H2, it's H1 plus HW. Last time, In the previous video, we already solved for the H1, and that is 8.8333 plus 0.6988. And eventually, your swell at point 2 is 9.5322 feet. And that's the answer. Now, for the part 3, we will solve H2 by not assuming, because in this case, first that we assume, we assume that we assume that PA is 22.2. But in the part 2, let's make it a variable.